Hello, welcome to this lesson of our study of differential equations. Okay, so this is particularly still on first order differential equations. Okay, so if this is your first time of watching my videos or any of my videos, kindly subscribe to support the channel. And also, if you want to know all the techniques in solving first order ODE, the ordinary differential equation, kindly check in my playlist. I have a playlist on that, and then you go through it step by step. Okay, so we've done a video on classification of ODE, homogeneous first order ODE and how to solve it, solving first order ODE with method of separation, and then also a video on solving first order ODE with linear coefficients. And now we are on exact differential equation, exact first order differential equation. Okay, so let's start with a simple argument here and see where the exactness of a differential equation is coming from. Okay, so here, given a function f of xy, okay, we know that from partial derivatives, okay, this is a function of two variables. The total derivative df, okay, the total derivative df is equal to differentiating f with respect to x times dx. So in partial derivative, you can also write del f del x, this side, as fx. Okay, then you write dx plus fy dy. Okay, where the fx is the same as this del f del x, and the fy is this. Okay, I hope you get my point here. So if this is true, then if the function f of xy, we have an equation that says that the function f of xy is equal to a constant c. Okay, then if I'm to differentiate or find a total derivative of this whole equation, then the f, meaning that I have to just find a total derivative of this f, okay, which is given like just above this. Okay, where my df is this one. Okay, should be equal to the total derivative of this side, the c. And when you differentiate the constant, we all know you get 0, meaning that we'll have something like df del f del x dx. So del is different from d. Okay, so del f del x dx plus del f del y dy should be equal to 0. Now if you realize, there is a way of also writing a first order differential equation in this form, that something dx plus something dy equals 0, which we call it the differential form. Okay, so let's compare that and see. Recall that we can write a first order ODE in this format, that m of xy dx plus n of xy dy, where your this form of representing the first order differential equation is called the differential form. Okay, so this is another way of representing a differential equation. Now you realize that this is what we had in our previous discussion, or in the just gone page. Okay, we had something like del f del x dx plus del f del y dy equals 0. Now if I'm to compare these two and say that there is a function f of xy that satisfies this whole differential equation format, or this representation. Okay, this representation, if there's a function f of xy that satisfies this, then it means that my m of xy will be equal to del f del x, and my n of xy will be del f del y. Okay, but in partial derivatives, del squared f del x del y, meaning that I just have to del squared f del x del y is the same as del y. In partial derivative, you do this first. Okay, so del y out, then you come and do this del f del x, and then with the other one, okay, is the same in partial derivative. This from Claira's rule, this thing, del squared f del s del y is the same as del squared f del y del s. Okay, so you can see that I can do the first partial derivative with respect to x, and then come and do it with respect to y, and it's true. And this should be the same as doing this with respect to y and come and do it with respect to x. This is from Claira's rule, and this is true in partial derivatives. But if you look through the boxes, you could see that m is representing, from this equation, m is the same as del f del x, and n is the same as del f del y. Okay, that is what we just said here. This shows that del y of m should be the same as del x of n, So if there's a function that satisfies this, then we call this if so this implies that del m del y is equal to del n del x, okay, from what we just did. So if this is true, then the differential equation we have is what we called an exact differential equation, and then it has a solution of this format, that there's a function f of xy which is called a constant c. Okay, so this is always the solution. So our task will be going to look for f of xy and then we equate it to a constant c, and that will be all. Okay, I hope you understood this. So let's pick some differential equation and check for their exactness. Okay, I think yes, the first one is, we have, with the a, we have 1 minus 2x, this one. Okay, so let me write it in the next page and we continue with the solution. Okay, so we have 1 minus 2xy. Okay, 1 minus 2xy. I'm sorry, my pen is 1 minus 2xy dx. Okay, let me write it again for you. So we have 1 minus 2xy then dx plus 4y cubed minus s squared dy, and this should be equal to 0. If you compare this to the general form, you say that your m of xy, let me call it m because we want to keep space here, okay, and your n of xy is the same as 4y cubed minus s squared. Okay, and we are saying that del m del y. Okay, so you always put in mind that m is the same as differentiating your function that we don't know with respect to x. So if I differentiate the m with respect to y, it should be equal to what? So this del m del y means that I'm differentiating this whole thing with respect to y only, and that will give me what? Holding everything constant will give you minus 2x. I hope you understand partial derivatives. So I have a video on partial derivatives. If you don't understand this, you can check that one too out. Okay, so we said the other one was del n del x. So always put it in mind that you do it for m with respect to y and then n with respect to x. Okay, and this is equal to minus 2x. So realize that they are the same. Okay, the m del y is the same as del n del x, hence we have exactness. So this differential equation is exact. Okay, I hope you understood this. So the first one is exact. Okay, so with the second one we have y cos x plus 2x rather. Okay, 2x e to the y plus, okay, so this whole thing plus sine of x then plus s squared e to the y plus 2 then dy dx, and all of this is equal to 0. Okay, so what will happen is that before you start, you have to convert this to the differential form. So it means you have to multiply through by dx. So when I multiply through by dx, I have y cos x plus 2x e to the y then dx plus sine of x plus x squared e to the y plus 2 multiplying dy equals 0. Okay, so there's only this part is multiplying dy. I hope you remember that. Okay, so you can see that this here m is equal to what? Y cos x okay, plus 2x e to the y, then your n is equal to sine of x plus s squared e to the y plus 2. So first of all, we said you should differentiate m with respect to y, and del m del y is equal to, differentiate the whole of this with respect to y, keep every x constant, and you have cos x plus 2x e to the y. Okay, the reason is very simple, because when you differentiate e to the y, you get e to the y again. Okay, that one too, I have a video on that, how to differentiate every exponential function and trigonometric functions. Okay, you can check that one too up. And del n del x is equal to differentiating n with respect to x sine x. When I differentiate sine x, I get cos x plus differentiating this term, the remaining term with respect to x, I have 2x e to the y, then plus the different derivative of 2 is 0. Okay, with any kind of variable is 0. So this means that they are the same, and hence this is equal to this. Okay, and hence we have exact. Okay, so this one is exact. So you take the last one, then you go and try it on your own, and then at the end you tell me what you got. Okay, because the solution is very simple. You get a value 12x plus 7y, okay, over 6y minus 7x. So you're supposed to show that this is exact, and also tell me what you get for the derivatives. Okay, all right, so this is very simple. This is a little introduction about exact differential equation. And this next discussion, you're going to take an exact differential equation and solve it. Okay, so how do you solve an exact differential equation? That's what we are going to do next in our next discussion. Okay, so thank you, and like I always say, don't forget to subscribe to my channel. Kindly share my videos, like it, and also comment. Your answer is needed in this particular question. Okay, so just comment and tell me your answer. See you next time.